everyone, I am Snigdha Bharadwaj, Assistant Professor, ITS College of Pharmacy. I welcome you all in my session. So, in this session we are going to discuss about pharmacokinetic parameters again. So, let us get started. So, basically in our previous sessions of pharmacokinetic parameters, we have discussed about volume of distribution, elimination rate constant, absorption rate constant and clearance. So, now in clearance only we will talk about various clearance models. So, how we can identify or analyze the value of drug concentration eliminated from the body fluids. So, we use different kinds of models. So, first the calculation of clearance from K and VD. Basically, K is your elimination rate of your drug and VD is a volume of distribution. So, as the calculation of clearance from K and VD assumes sometimes incorrectly a defined model, whereas clearance estimated directly from the plasma drug concentration time curve does not assume any model. So, basically a defined model sometimes why we need these clearance models to identify the exact clearance value of the drug from the body. So, sometimes from K and VD if we analyze all these parameters to get clearance value, sometimes it may not give the appropriate values of clearance. So, concentration time curve does not assume any model basically. So, physiologic and organ clearance may be calculated for any oxygen involved in the irreversible removal of drug from the body. Many organs in the body have the capacity for drug elimination, including drug excretion and biotransformation. Although we have discussed in detail in our earlier sessions. So, clearance may be how much drug is eliminated at a particular time. So, it is represented clearance from the blood plasma. So, rate of elimination by an organ is equal to rate of presentation organ input, right, minus rate of extraction organ output. So, basically QC in and QC output, organ input and organ output. So, this is the difference. The difference will give you the rate of elimination by an organ. So, basically each organ has its own capability to eliminate the drug at particular time period, right. So, based on its efficiency or condition of working. So, any drug can be eliminated by any organ in different manner, right. So, where the clearance estimated directly from the plasma drug concentration time curve does not assume any model. So, from plasma concentration time curve, what we are doing? We are observing different pharmacokinetic parameters and analyzing those to conclude the clearance results, right. So, we are doing the same thing. So, with this the rate of elimination by an organ. So, the rate of presentation organ input, yes, coming in and going out, right. So, what are the clearance models we generally study? Compartment model, physiologic model and model independent approaches. So, we have discussed various types of models earlier also. So, these are physiologic organ clearance specific to clearance methods. So, clearance may be calculated from any organ involved in the irreversible removal of drug from the body. Yes, drug is not getting again absorbed once it is eliminated from the system. So, kidneys and livers are the main organs which are responsible for drug excretion and elimination, right. So, from kidneys the drug will be excreted through urine and liver metabolize the drug, or it can be excreted the drug in the bile formation, right. So, physiologic models are based on drug clearance through individual organs or tissue groups. So, physiologic models basically are based on drug clearance through individual tissue and body organs. So, basically we are taking not the compiled or sum of the total body clearance, we are just analyzing a body clearance from a particular tissue or organ. Fraction of blood volume containing drug that flows through the organ and is eliminated of drug per unit time. So, basically fraction of blood volume we are collecting and analyzing for drug content or drug concentration that flows through the organ and is eliminated of drug per unit time. So, clearance will be calculated by this formula. Clearance is equal to blood flow Q, extraction ratio ER. So, ER is equal to Ca minus Cv divided by Ca. So, extraction ratio, we assume that a drug entering to the particular organ, if it is not eliminated in that proportion, exact proportion, that means the organ is sometime extracted the drug, right. So, ER is represented at Ca minus Cv divided by Ca, and Cl is equal to Q, that is blood flow Ca minus Cv divided by Ca. So, basically this is coming in concentration and going out concentration, and this is the blood flow. So, extraction basically is the difference value of this particular extraction ratio. So, blood flow rate and ability of the organ to eliminate the drug requires invasive techniques to obtain measurement of blood flow and extraction ratio. So, QCA blood flow and the amount coming into a particular organ, elimination organ, and then QCV drug eliminated and amount of blood flow. So, elimination drug. So, Q is equal to basically your blood flow, Ca incoming drug concentration and Cv outgoing drug concentration. How much drug is coming to a body organ, elimination organ, and how much drug is eliminated. So, this may be a variation sometimes. So, basically extraction ratio can be calculated using this previous equation. So, model independent methods. So, clearance is commonly used to describe first order drug elimination from compartment models such as the one compartment models. We have already discussed it in our earlier sessions. Model independent methods are non-compartment model approaches used to calculate certain pharmacokinetic parameters such as clearance and bioavailability. So, we did not discuss much about model independent approaches. So, when we adopt model independent approaches, so we analyze various pharmacokinetic parameters like clearance and bioavailability, and overall we can assume and we can observe the plasma drug concentration through these parameters and rate of elimination through these parameters. The major advantage of model independent method is that no assumption for a specific compartment model is required. Sometimes when we talk about compartment modeling, then we are considering body and body organs as a single or multiple compartments, and then we set the calculations and analyze the data, experimental data, to correlate it with the mathematical formulas. But in a model independent approach, there is no such assumption. We consider like one compartment and body compartments. So, it is a linear equation we follow, or linear type of representation we follow sometimes for drug plasma, for identifying drug plasma concentration and clearance. So, the moreover the volume of distribution and the elimination rate constant needs not to be determined. So, we do not need to determine the distribution volume of apparent volume of distribution and elimination rate constant in that case. Model independent method, plasma drug concentration time curve. So, calculate certain pharmacokinetics like clearance and bioavailability. So, advantages are no assumption for a specific compartment model is required to analyze the data. The volume of distribution and elimination rate constant need not to be determined. So, how we can determine the clearance from model independent approach? So, clearance may be determined directly from the plasma time concentration curve by CL using this equation CL D naught CT dt. So, CLR is the renal clearance, D naught AUC 0 to infinite time. So, this is the time value we have given at time 0 and infinite time. So, AUC is equal to Cp dt. So, D naught is equal to basically a dose, CLT unknown function that describes the declining plasma concentration. So, basically this is the function which represent the change in drug concentration in the blood plasma. So, here we can calculate the clearance from using these particular parameters, because this concentration can be analyzed using different samples and different time intervals. So, compartment modeling after model independent approach. So, compartment modeling utilizes static volume and first order elimination basically is assumed. Plasma flow is not considered in that case. So, the basic calculation formula basic formula will be CLT clearance, total clearance is equal to K V D. So, physiological model uses the equation like CLT is equal to Q ER. Q is blood flow, ER is your extraction ratio. Clearance is the in physiological model, clearance is the product of the plasma flow, and in model independent, volume and elimination rate constant not defined. So, in compartment model you just assume VD Cp. So, volume of distribution and concentration in plasma. So, static volume and first order kinetics is assumed, plasma flow is not assumed. So, CLT is equal to KVD, will be KVD. Physiological model QCA, it is of blood flow and concentration coming in the system, organ and eliminating out. So, the equation will be CLT QER, and in model independent approach we generally do not assess elimination rate constant and volume of distribution. So, equation will be CLR D naught AUC 0 to infinite time. So, this is these are different approaches. Now, after the general concept of clearance and clearance models, we basically focus on clearance, renal clearance, how we can calculate. So, renal clearance is defined as the volume of plasma that is cleared of drug per unit of time through the kidney. So, now we are talking about the clearance from the kidney. So, that is known as renal clearance or CLR, represented by CLR. Volume of plasma that is cleared of drug per unit of time through the kidney. Similarly, renal clearance may be defined as a constant fraction of the VD in which the drug is contained that is excreted by the kidney per unit of time. More simply, renal clearance is defined as the urinary drug excretion. Yes, because the drug is excreted in urine through the kidney. So, we can also termed as urinary drug excretion and defined as the urinary drug excretion rate du by dt divided by plasma drug concentration. So, CLR will be excretion rate, plasma drug concentration, and it will be represented as du by dt Cp. So, mathematical expression can be like this. So, consider the mass of balanced drug cleared by the kidney and ultimately excreted in urine. So, rate of drug passing through kidney is equal to rate of drug excreted in urine. So, the formula will be CLR Cp is equal to Qu and Cu, urine. U represent the urine. CLR is equal to renal clearance, Cp plasma drug concentration, Qu rate of urine flow, Cu urine drug concentration. So, CLR will be like Qu Cu divided by Cp. So, QU, CU represent excretion rate, and whereas Cp is plasma drug concentration. Comparison of drug excretion methods. So, CLR basically rate of filtration plus secretion minus reabsorption. So, in kidney or we can say renal excretion, so various methods are involved, rate of filtration, secretion, reabsorption divided by plasma drug concentration. So, we take all the processes value and divided filtration plus secretion minus reabsorption. So, divided by plasma concentration. So, the renal clearance ratio will be CLR of drug and CLR of creatinine. So, the ratio is calculated using this. Actual clearance is not obtained by direct measurement compared to that of standard and standard reference such as insulin. So, clearance ratio basically it is an indication for the mechanism of renal clearance or renal excretion of the drug. So, through this we can get the information about the exact mechanism the drug is basically following for its organ is using for its clearance or excretion. So, determination of renal clearance by graphical method and model independent method. So, graphical method basically slope of the curve obtained by plotting rate of drug excretion in urine du by dt against Cp for a drug that is excreted rapidly, that means du by dt is large, the slope is steeper and clearance is greater, right. For a drug that is excreted slowly through the kidney, the slope is smaller. So, this is how if the drug excreted rapidly, the clearance will be greater, and if it is not excreted slowly through the kidney, then the clearance will be not so much. So, clearance from kidney, urinary drug excretion rate divided by plasma concentration. So, here du by dt and Cp. So, A and B. So, these are the two different drugs, rate of drug excretion and plasma level. So, du by dt. So, this is compound A, this is B. So, you see that the steeper one has greater renal clearance value, and this B has smaller clearance or slow clearance we can say. So, slope is your renal clearance. These lines are representing the clearance of the drug product from the body. So, the graphical mathematical formula will be CLR du by dt by Cp, multiplying both sides by Cp gives CLR Cp du by dt, right, by rearranging and integration. So, du du CLR at time 0 at time t Cp dt, and by simplifying the equation at last we will get du 0 to t CLR AUC. So, basically drug excreted in urine can be represented in the form of T1 and T2 time intervals, two different time intervals we can take, and slope will give you the value of CLR or AUC will give you the value of this plasma concentration. So, these equation we can use for calculating clearance renal clearance using graphical method. Non-graphical calculation from the knowledge of clearance like AUC, FD, DU, fraction of drug remaining to be eliminated, area under the curve, and DU, U to infinite, drug in urine. So, clearance will be D naught AUC 0 to infinite time. If total amount of drug excreted in urine D u to infinite has been obtained, then clearance is calculated by using this equation CLR du infinite and AUC. So, basically it is a drug present in amount excreted in urine, and this is the plasma drug concentration value. So, model independent method advantages are rapid and easily obtainable estimates of drug clearance we can easily obtain, and disadvantages are calculation does not reflect non-linear changes in the clearance rate. So, basically sometimes we get variation in data which cannot be correlated with each other. Now, after renal clearance, creatinine clearance also be discussed. Volume of blood plasma that is cleared of creatinine per unit time is useful measure for approximating glomerular filtration rate. So, it is used to determine renal function, basically the function of kidney, whether it is working fine or not for excreting drug. Endogenous amine produced as a result of muscle catabolism excreted unchanged in the urine by glomerular filtration only. So, advantages are it can be correlated to steady state concentrations of creatinine in plasma and needs no collection of urine. So, basically we can identify steady state concentration from plasma itself, no need to collect urine at different time intervals. So, creatinine clearance, it is a determination of serum creatinine level. So, the formula will be C1 creatinine symbol C140 minus age into body weight kilogram serum creatinine mg per liter and 72. This formula can be calculated for specifically males. So, direct method for determining clearance will be like CLR, renal clearance, rate of creatinine clearance and serum creatinine in milligrams percentage. So, this is how we calculate creatinine clearance. So, rate of creatinine clearance and serum creatinine in mg. So, normal value lies between 120 to 130 ml per minute. So, this is how you calculate creatinine clearance. So, total body clearance, the sum of individual clearances by all eliminated organs like CLT. So, we have different clearance, total body clearance K is represented as KVD, CLR KEVD, CLH KMVD, CLT CLR plus CLH and K is equal to KE KM. So, these are basically constant. So, this the sum of individual clearances by all eliminating organs will give you the value of total clearance of the drug from the body. So, once again we discuss the highlights of this session, that we have discussed various clearance models. First is compartment, physiologic and model independent. The basic differences in all the models is the compartment model, static volume and first order elimination is assumed, plasma flow is not considered, and whereas in physiologic models basically we take the blood flow in the particular organ and extracted ratio, and in model independent we do not assume elimination rate constant and volume of distribution, and we can use the different equations to calculate the clearances. Now, after that we discussed about renal clearance. So, using different mathematical expressions we can calculate renal excretions. Renal clearance ratio is also dependent on the rate of filtration and secretion and reabsorption. So, we always consider all these processes while calculating renal clearance. So, after this renal clearance can be calculated using two methods, graphical and model independent. In graph basically you see that we generally represent the data in form of figure, and these slope represent the renal clearance value, and on a y axis we took rate of drug excretion, whereas in on x axis we take plasma level concentration. So, graphical method using this derivation can be attained the values of renal clearance. Non-graphical calculation from the knowledge of AU, CF, D and DU. Basically, DU is here drug excreted in urine has been obtained, the clearance from the below formula given. Now, these are the advantages and disadvantages does not reflect. Basically, advantages are rapid and easily obtainable estimates of drug clearance, but disadvantage, it's not give the, sometimes it does not give the non exact representation of the data. So, after that, creatinine clearance. So, using this formula we can calculate creatinine clearance. Basically, CLR is equal to rate of creatinine clearance divided by serum creatinine in mg. Normal value lies 120 to 130 ml per minute. Total body clearances can be used different can be calculated using these different formulas written and analyzed properly. So, these are references. I hope you understand the concept of body to different types of clearance of drug from the body. So, in next lecture we will be continuing with the same pharmacokinetic parameter studies. So, till then, take care, stay safe. Thank you.